this video, we're going to look at a few other terms, range, outliers, and a trimmed mean. And in this video, we're going to look at finding the range for a data set, identifying outliers in a data set, and calculating the trimmed mean for a data set. The outcomes we're going to cover include identifying the outliers in a set of data, explain the effect of outliers on mean, median, and mode, calculate the trimmed mean for a set of data and justify the removal of outliers, and explain using examples from print media or other media how measures of central tendency and outliers are used to provide different interpretations of data. So a few important definitions to start. The range is the difference between the largest value and the smallest value of a data set. And an outlier is a value that is much smaller or much larger than the other data values in a set. A data set may have no outliers, there might be only one, or there might be more than one outlier. And an outlier may be due to an error in data entry, or an error in calculation, or it may just be due to some odd behavior. So the first thing we're going to look at is the range of the following data set. And we're also going to identify the outliers. So the data is 20, 34, 20, 15, 3, 20, 6, 10, 13, 16, 10, 50, and 21. First thing we're going to want to do is order the data from least to greatest. Smallest number is 3, then 6, and so on and so forth, and here we go. This is the data in numerical order from least to greatest. To find the range, what we have to do is subtract the least number, in this case 3, from the greatest number. In this set of data, the greatest number is 50. So my range is 50 take away 3, or 47. So there's a range of values that are 47 numbers in difference. The outliers in this data set are values that don't fit with the rest of the data set. So once again, I'll have you look at them. When we look at them from least to greatest, you'll notice, first off, that 50 is a clear outlier. Well, 34 is also much higher than anything else. All the other data numbers are within about 2 or 3 each from as you go progressively higher. 3 and 6 can also be considered outliers. Some may argue with that statement, but they are smaller than the rest of the numbers. All the numbers seem to fit between 10 and 21 fairly succinctly, except for the 2 at the very ends, both larger and smaller than the middle data. When we have outliers, often it's useful to calculate a trimmed mean. A trimmed mean is a calculation of your mean found by removing the highest and lowest values. If you ever watch the Olympics, you'll see this a lot in figure skating and I believe in diving. Anytime there's judging going on, there's often the removal of the highest and lowest scores to try to give everybody the best average, because the highest and lowest scores can sometimes be considered outliers. So in a trim mean, you must remove the same number of values from the top and bottom of the data set, from the least side and from the greatest side. So if you remove one outlier from the top of your data set, you have to remove the smallest number as well. If you remove 2 numbers from the high end of your data set, you have to remove 2 numbers from the bottom. And by removing outliers, it can result in a more accurate mean. And in terms of judging, in figure skating or gymnastics or other judged events, is to try to get it things as fair as possible. Okay, we're going to look at the effect of outliers on measures of central tendency. The table below shows NHL point leaders for 2 different seasons, 1985-1986 You can see the values here. Wayne Gretzky with a high score of 215 points. Denis Savard had 116 that year. In 2010-2011, the highest scorer in the league was Daniel Sedin with 104 points. And we have at the other end of our points leaders table here, Alex Ovechkin with 85 points. So the first thing we're going to want to do is calculate the range for each set of data and also the mean for each set of data. So we're going to start with the ranges. In 1985-86, the highest value was 215 points, and the lowest value on the list was 116. So there was a range of values of 99 points from the highest to the lowest on this list. In 2010-2011, the highest value was 104 points, and the lowest value was 85 on this list. So the range of values for the top 7 scorers in 2010-2011 was only 19 points in difference. The mean for 1985-86, if you recall, to calculate a mean, you add up all the numbers together. We have them here: 215, 141, 138, 131, 123, 122, and 116. And there were 7 values in the data set. So we add them all together, that equals 968 points over 7 players, which works out to an average of 140.8 points per player. In 2010-2011, the 7 top scorers in the league totaled 657 points in total, which worked out to an average of 93.8 points per player. So when you look at the lists, which value appears to be an outlier in one of the 2 seasons? Explain what might have caused the outlier. Well, the outlier, one back more. The outlier, I think it's kind of obvious, it's right here. That number is so much bigger than anything else on our list. Oh, gone too far. Okay, so the outlier was Wayne Gretzky's total in 1985-86. Wayne Gretzky scored 74 more points than the nearest competitor, Mario Lemieux, in that year, while the difference between all the other point scorers in the league in those 2 years is within 4 or 5 points each. So it's a big jump from the highest point getter in the league that year to the next highest. What would be the cause of this outlier? Well, in this case, it wasn't anything to do with data entry errors or calculation errors. It's just Wayne Gretzky had a really, really good year in comparison to anyone else in the league. So sometimes, like I said, an outlier may just be to some odd circumstance. Okay, what we're going to do now is remove the highest and lowest value for each season. And by doing that, we're going to find the trimmed mean. How does the trimmed mean for each season compare to the mean calculated in Part A? So we're going to look first at 1985-86. If you recall, there was 986 points in total for the 7 players. But if you remove the highest and lowest point totals, we remove Wayne Gretzky's total, 215 points. We remove Denis Savard's total, 116 points. Then that leaves us with only 5 competitors that we're comparing. And of those 5 competitors, they totaled between them 655 total points, which works out to an average of 131 points per player. So how does this compare to the original mean we calculated? Well, if you recall, the original mean was 140.8 points per player. So the trim mean has a big effect. The mean has dropped by almost 10 points due to the outlier, Wayne Gretzky's score, being removed from the list. In 2010-2011, we take the total number of points, which was 657 total points. subtract the highest score, which was 104, subtract the lowest score, which is 85, and that leaves us with just 5 competitors. Between those 5 competitors, they had an average of 468 points total, which leaves them with an average of 93.6 points. The mean before we trimmed it was 93.8. The mean after we trimmed it was 93.6. So that means the trim mean had very little effect. The means are almost the same. They're off by 0.2 points. The reason is because there were no outliers in this set of data. All the data points were roughly a couple of points apart from each other. So no numbers really stood out either in a greater fashion or a less than fashion. So should the outlier be removed? Should Wayne-Gretzky's score be removed from this list when we want to compare? Explain why or why not. Well, the answer is that it really depends. It depends on what purpose we're making these calculations for. If you want to show how good Wayne Gretzky was that year, he alone added to the list of point getters for that year adds about 10 points on average for all the top 7. So if you want to show how good Wayne Gretzky was that year, then you should probably leave his number in. But if you want to get a better comparison of what the league scoring averages were in 1985-86 compared to 2010-2011, it might be a good idea to remove it because, again, that seems to be freakishly good in comparison to anyone else involved that year. So it's not a fair comparison to include his numbers necessarily. So to summarize, the range is the difference between the greatest and least terms in a set of data, the largest and smallest numbers, in other words. An outlier is a number in a data set that is much larger or much smaller than the others. And again, there may be none, there may be many, there may be one. And outliers may be due to errors either in data entry or in calculations, or it could just be due to some random odd event. And finally, the trimmed mean is a way to calculate a mean by removing outliers. The same number of terms must be removed from the low end and the high end of a set of data if you want to calculate a trimmed mean. So again, you can't drop the top 2 terms in a set of data and not drop the bottom 2. They have to be an equal number dropped from the top and the bottom in a set of data.